All right, welcome to lesson 7. We are going to move forward in our physics understanding. If you guys remember right, remember back from the beginning of the year, we went through constant motion, then we moved to acceleration, which was lesson 6 from last week. We then moved into free fall, which then led us ultimately into projectile motion. We kind of put the the constant motion and the free fall idea together. So we're going to use this idea to move into our projectile motion coding here. So you now have enough coding knowledge to attempt to figure out this one on your own, of course. So I'm going to give you a little bit, but just like last week, the actual lesson, the challenges and the assignment, you're going to have to figure out on your own. I'll give you a little bit of help. But so first thing you're going to want to do is copy your lesson 6 code into your new project, because it's pretty much going to be the same thing. We want an accelerating object in one direction, and then we want it to be constant motion in the other. So make some modifications to try and get the object to move in projectile motion. You won't have to change anything too drastically. Keep it simple, of course. I have the code here for you, so I would recommend trying to figure this out on your own, but I'll definitely, once again, just keep going with this. If you want to just put the numbers in, that's fine. Just hopefully you have an understanding of why we're doing these certain things. So we need to make some modifications. You're going to need only to make a couple, of course, so it's not going to be that difficult. For your ball.v, or our ball velocity value, we want, in this case, the initial velocity. We want to change that so that it has both x and y values, because not only do we want it to move across the platform, we want it to move up as well at the same time. So we need to give it an x velocity and a y velocity. And of course, initially, our final velocity will be exactly the same. At time equals 0, the initial and final velocities will be the same. As time goes on, the numbers will change accordingly. We also need to change our acceleration value. So before we had an acceleration in the x direction as it's moving across the platform. Well, we know with free fall that acceleration is not in the x direction, but in the y direction, and it's also pointing down. So we need to add that in there. So in the y part, instead of 0, we're going to put negative 9.8 or 9.81 if you want. In our acceleration for the ball in the y direction. Once again, no acceleration in the x direction, because there's no acceleration that way in an ideal situation. And then, of course, my initial velocity, or my initial position, was the same as the one that was up here that I changed those numbers around a little bit. So you'll have to play around with that. So anyways, what I want you guys to do is play around with some of the values and see how you can manipulate this. Maybe see how this is going to change if you were on Mars or on the moon or whatever. Change this acceleration value. Just look it up. Just look it up on just Google search, acceleration on the moon or acceleration on Mars, and change the values around. All right. But anyways, play around with that just to get used to it. Your assignment for this week, and I'll post this, of course, to Google Classroom with a list like normal. Number 1 is to create an object that moves horizontally at a constant rate. So like before, we had the one that moved across. This way you're using your code from last week. But I also want you to have another object that moves via projectile motion, and when that object hits the ground, it's going to strike the object. So for instance, I'll run my program and you'll see this. So I'll have another object that's moving underneath this one, and when that purple ball hits the ground again, it will strike that object that's moving at a constant motion across the ground. All right. So your job, your first assignment is to make the projectile motion work, and then have a second object moving underneath it, so that when this one strikes the ground, it'll hit it. All right. Kind of like a target practice or something, right? For the challenge, I want you to have the constant velocity object, give it a 5-second head start before the projectile motion object starts. All right, so let the constant motion one move across, and then the projectile motion one will start 5 seconds later. For an extra challenge, and this is a preview of next week's topic a little bit, I want you to figure out how to include air resistance in the x direction of projectile motion. So we've been dealing with ideal situations all the way through. I want you now to add air resistance. So how would you do that? How would you represent motion with air resistance? All right, so you got to think about that a little bit. What's going to happen? Really think about it. What's going to happen to the motion of this object, and why is it going to happen? What's changing? And then adjust your code accordingly. You only have to change a value, so you don't have to make it too complicated. All right, so keep it simple, of course. So I want you guys to make that happen so that when you launch it with the air resistance, it will not hit the target, but by removing air resistance, it will hit the target. All right, so that's your goal for the extra challenge at the end of this one. All right, anyways, play around with that as much as you want. If you have any questions, please don't be afraid to email me. Have fun.